Warning: this video contains some actions that may not be safe. Please be cautious, and we claim no responsibility for any injuries obtained from building this device.
Hey guys, in this video we're going to show you how to configure your APM 2.6 flight controller on your S550 Hexacopter. Okay, so to start things off, like all of our other videos, you're going to need to gather your parts. We have our S550 Hexacopter frame right here. You're going to need that. You can learn how to build that in our last video. You can use also any other multi-rotor. We just happen to be using S550 here. I like it because it can lift a lot of weight. Down to the smaller parts here. You're going to need a Spektrum DX 5V radio, or of course you're going to need your APM 2.6 flight controller, a micro USB cable to program that. For the APM 2.6, you do need a vibration dampener mounting for it, because otherwise you'll get weird spasms and unnecessary vibration in flight. You'll need some form of small adhesive square to mount your APM 2.6 onto your anti-vibration plate. You're going to need a GPS module. The APM 2.6 does not have an internal compass or GPS. You're going to need to get an external one. Make sure it comes with one of these GPS sticks, because otherwise you're going to get interference from your ESCs. You're going to need some small jumper cables here. These are going to be used to connect your APM with your receiver. My APM only came with 4 of them, but you're going to need a 5th because you're going to need an auxiliary channel. You're going to need some carbon fiber propellers. The S550 comes with plastic ones, but those things are so fragile that if you just tip over your quad slightly, they'll just shatter. So make sure you get these carbon fiber ones. They're like 20 bucks for 8 of them. The total deal, and they're basically indestructible. You're going to need some propeller caps here. These caps should also have come for free with your Hexacopter. You're going to need a receiver, and if you haven't already bound, you're going to need a bind plug. You're going to need a pair of Longnose / Needlenose pliers. You're also going to need one of these screwdriver sets. This includes hex wrenches, so keep that in mind. But these things are really great. They're pretty cheap. They're like 10 bucks off of Amazon, and they have absolutely everything you need in it. You're also going to need some wire cutters. You're going to need an assortment of zip ties. You're going to need a bunch of long ones and then a bunch of short ones. And you're also going to need some M2, I believe, screws with lock nuts. This should come in your S550 Hexacopter kit if you got one. Otherwise, you can just order them online. And of course, you're going to need your S550 Hexacopter. We built this in our last video. If you haven't already watched that, make sure to go check it out. The link is right in the description below. For the first step, you're going to want to download your software. We are here at arduPilot.org/index.html, and this is where you're going to be downloading your software. So to get to your software from here, you're going to want to go to APM Planner 2, because that's what we're going to be downloading. You want to scroll down here. You want to click Mac OS X for me, and you're going to say download the latest Mac installer file, and that's going to be here. Click that. There you go. And once you're done downloading it, you're going to want to run through that DMG file for Mac and just get that thing completely installed, and then power it up, and let's start programming the APM 2.6. The USB port on the APM 2.6 is actually located on the back here. It should be labeled USB. You can take your micro USB and you can plug that in. Once you have that plugged in, you can now take it over to your computer. and you can plug it in through one of your USB ports. When you power it on, you should see some lights flash. There you go. Got that flashing red light and blue light, and we got that green light. Just like that. Now we can go back into the software and flash our firmware. Okay, so here we are after we've downloaded it in the APM planner here. This is where it will show you where your drone is located once you install GPS. This will tell you the orientation of your drone. And over here, this will tell you your altitude and a bunch of other stuff. But none of that's going to work until we set it up. Just really quick, if your map isn't working, just make sure to go down to here, options, and then under map type, it will default at Google Hybrid. Just set it to Google Map, because for me, Google Hybrid has never worked, so don't even bother. Okay, so to flash our firmware, we're going to go to Initial Setup, click the Install Firmware button, and we're going to select our type of multi-rotor. So we are using a Hexacopter, which looks just like this one, and it's going to ask you, are you sure you want to install this? And you say yes. Then it'll start flashing it, and it should automatically pull up your port here, but if it doesn't, go online. There's tons of forums that can help you on this stuff. It's super easy, and there's really great answers. Okay, once your flashing is complete, you can press OK. Now that you have your firmware flashed, on to the next step. So now we are finished downloading our firmware, we can work on setting up the controller. We're going to go back into Initial Setup, and we're going to press the little button that says Connect in the corner. It'll say Connected, and then in a second, yep, there we go. Our mandatory setup will pull down here. We have to complete all of this for it to be able to fly, because the flight controller actually runs pre-arm checks. It checks a bunch of things before it'll even arm, so this all has to be done. Just double check your frame type, and yes, we do want an X frame type, because that's the S550 there, but if you have another type of frame, you can select that here. We're going to skip the compass calibration for now, because the APM 2.6 does not have a built-in compass, so we're going to have to calibrate it once it's on the Hexacopter mounted with the compass. We're going to skip directly to calibration, which is short for accelerometer calibration. Okay, so here we are on accelerometer calibration, so we're going to press calibrate accelerometer. Now it says place vehicle level and press any keys. The APM flight controller here, as you can see, is level because it's on this nice flat table. So we're going to press here. Now it's going to say place on its left side. So if you notice, there's actually an arrow pointing this way right next to the label. It says GPS. So that is its forward. So if that is its forward, then this is its left. On its left. Press that. Now you're going to place it on its right. Just like that. Now you want to place it nose down. So if that's forward, then nose down is just like that. Now nose up. If that is forward, then nose up. That's the nose. So it would be like this. Now you're going to place the vehicle on its back, which is this. So that's just going to be flat, just like that. And there you go. Calibration successful. Okay, it is now time to wire your receiver to your flight controller here. So to do this, you're going to need 5 jumper cables. And you're going to be connecting your roll/aileron, pitch/elevator, throttle, yaw/rudder, and auxiliary 1. You need an auxiliary channel because you're going to need to switch flight modes. It is mandatory. So make sure you have at least a 5-channel radio to do this. That's why I'm using the DX5E. This is a Spektrum compatible receiver. This one is really nice. It's not anything fancy, but it's good. And I'm going to be referencing this, and I'm going to connect them with these small jumpers. My APM came with 4 of these jumpers, but I needed a 5th one, so that's why I soldered this up. When doing this, remember that the black is negative, and on your receiver that goes at the bottom, and on the APM the black faces the outside. There you go. If you're wondering where I got this photo, you can download it from Google Images. Just search APM 2.6 inputs, and it'll pull up this. You could also just go to rgpilot.org, and if you look around on that site there is this image, and of course you can just click it and say download. And I just printed this out. It's really handy. And to bind your receiver to your remote, I'm just going to let you follow your remote specific and receiver specific instructions, because it really depends on what type of transmitter and receiver you're using. So mine's already bound though, so we can now go back into the software and calibrate our remote. Okay guys, now that you are done with wiring up your receiver to your APM 2.6, you can go into your mandatory setup and go into radio calibration. So under radio calibration, you will see your bars here, and this is just the reading that it's getting from the throttle channel, pitch, yaw, roll, and so on. So as you can see, when I bring up my throttle, the throttle goes up, and all the other ones do too when I move them. Just like that. So for this, we're going to calibrate it, and what this is basically going to do is going to set a minimum and a maximum level that it's going to be receiving. So to do this, you're going to move all your sticks and all your switches in every single possible direction as much as possible. So if you have a high mode on your remote, probably a good idea to set it to that right now. So when we press calibrate, give you that message, yeah. Okay, and it'll tell you move all your sticks to their extreme positions and watch the max values to ensure that you get the most range from your controller. This includes all your switches, so make sure to do your switches. So you're going to move your throttle up and down, your yaw. There we go. Now we can work on the pitch and roll. Okay, and now we can click our auxiliary channel 5 switch. Now we're done. Make sure to set your sticks back into their normal positions, so the throttle's down, and then your stick furthest to the right, which is your roll and pitch. If you're using mode 2, keep that in the center, and you can press end calibration. There, will give you that message, and then you can click OK. And there you go. Now you got that done, we can move down to explaining flight modes, and then finally setting up our fail-safes. So there are a few main flight modes, the first one being stabilize. So stabilize mode basically allows you to fly your multi-rotor device manually, but it automatically levels the roll and pitch axes. Next we have altitude hold, which holds your altitude. Next we have autopilot, or auto, which stands for autopilot, which basically means it'll follow a flight plan, which you can set up over here in flight plan. I'm not going to be doing this in this video, but we may create one later. You have loiter, which basically means your multi-rotor device will hold both its altitude and its position. RTL, which stands for return to launch. And land. Land basically means land. Those are just the basic common flight modes. You almost always want to arm and stabilize, so almost always you want to keep flight mode 1 in stabilize mode. And as you can see, when I flip my auxiliary switch, it switches down to here. That little green bar means that I am using flight mode 6. So if I want, instead of loiter, I want return to launch, I can just say right, and then if you see when I flip this, it'll say RTL, but my RTL is red because I don't have a compass attached. Okay, so if you guys are wondering what simple mode is, it's actually quite simple. Simple mode really means that no matter where the front of your multi-rotor device is, it'll still respond as if it were facing the same way that it took off in. For example, if you take off while it's facing, the front is facing away from you, you fly and you spin it around a bunch and you lose the front, or whichever position is the front. So when you move your stick back to get it to come back to you, even though the front is facing some random direction that isn't the way that you took it off as, it'll still fly back to you as if whichever way is directly in front of you is the front. Okay, now we can go down to failsafe. So we haven't attached our flight controller to our S550 yet, but if we did, make sure all your propellers are removed. For the fail-safes, you really don't need a battery fail-safe, because by the time your battery voltage reaches a low enough level for the fail-safe to kick in, you will have already noticed like a minute or so before that your battery's starting to run low, and that'll give you time to fly down and land. Really, the battery fail-safe isn't necessary, but if you really want to, sure, go ahead and enable it. I would strongly suggest using the throttle fail-safe, although my receiver is a very inexpensive one, so it doesn't have the capability of a throttle failsafe. The slightly more expensive receivers, when it loses connection with the transmitter, it will drop down a decent amount of its reading here. And that is good because you can set that value here for your failsafe. Mine doesn't do that though, so I'm not even gonna enable my throttle failsafe. And for what I'm going to be doing, I don't really need a throttle failsafe. I'm not going to be flying super long range FPV or anything. But in general, it's a good thing to enable if you happen to have the receiver. I just currently don't have an expensive receiver. There you go. We have our basic stuff done that we can do with our APM without the compass. We are now going to move on to mounting the APM onto our S550 and installing the compass and all that stuff. Okay, so now it's time to mount your APM to your anti-vibration plate. To do this, you're going to need your APM assembly with your receiver attached, a adhesive square, or you could use Velcro dots. I'm using Velcro dots. I have 4 small 10mm Velcro dots. I'm just going to be using 1 in each corner, and I'm going to be sticking the APM on just like this. So I'm just going to quickly do that. Just like that, push that down, and now that we have our APM mounted to our vibration dampeners, we can mount that on the Hexacopter. So to mount your APM on your Hexacopter, what you're going to do is take your APM with dampeners and lay that right around the middle. And if you'll notice, there's 4 screw holes on your dampeners. 1, 2, 3, 4. And there's also 4 on the Hexacopter. And these should align right up if you lay it over. Before you screw your APM in though, make sure that your APM is facing forward. So on the Hexacopter, the forward is labeled right here with this little golden arrow that says S550 and points forward. And on your APM, there's a little forward arrow here, and that says forward. So make sure that you point your APM in the proper direction. Okay, now you can start to pop in your screws. Now that you have your screws in, what you can do is you can take your lock nuts here and your pliers and pinch a lock nut in between your pliers, just like that. And what you're going to do is you're going to take your lock nut and stick it under the screw, and then screw the screw in from the top while you hold the lock nut in place. There we go. Now we have our APM mounted onto our Hexacopter. Okay, now you can mount your receiver. You want to make sure to mount your receiver on the right side of your Hexacopter if you are facing it from the front. So that is this side for me. It should be next to all of your pinouts here and next to your telemetry input there. You want your receiver to be mounted like that, and we are going to be threading our zip tie through these 2 slits here. You can see there are 3 slits, 1, 2, 3. We're going to be starting to thread our zip tie through this one and then come out through here and then zip tie it back. And there we go. It was important to install your receiver here because your GPS module is going to be mounted over here. Okay, for this next step, we're going to be mounting our GPS and compass module here. Make sure yours is installed on the stick, and for this you're going to need your GPS and compass module installed on your GPS and compass module stick, and one of your lock nuts here. I'm going to be installing mine right here. If you notice there's a bunch of holes in between these slits here, I'm going to be installing mine on the second hole. To do this, simply push peg in through this small hole, and take your pliers, and take your lock nut, and then install it from the bottom and twist it on. There we go, and when you finally get your GPS module installed, if you'll notice there's actually a arrow, slight dimple there on the top. Make sure that faces the front of your Hexacopter. So there you go, now you have your GPS module installed. It is very simple to plug it in. There should be 2 plugs coming off of it, and they should pop into the 2 plugs on your APM on the side. One is labeled GPS, and that will go to the larger one. That can be plugged in there. And then this smaller one goes to the port that says I2C. Just like that. And next we will move on to wiring up the ESCs. Okay, before we can install our ESCs, we have to label our arms and our ESC wires. If you look at this photo here, it tells you the Hexacopter rotor numbers. This is the design of the S550 here. It is a Hex X design. And so that means this is arm 1. This is arm 2, this is arm 3, this is arm 4, this is arm 5, and this is arm 6. If you notice, it kind of goes across in that way. We want to label that with a Sharpie. I already have in each of these corners. Okay, so according to that, you want to label your ESC wires. I just wrote the number of the arm on the little connector here, like this one says 4, and so on. So make sure to label that really quickly, and then we can start plugging them in. It says here on your flight controller, outputs, and then there's 1 through 8 here. And we're going to plug ESC wire 1 into port 1, and so on, all the way up till 6. And once again, when you do this, the negative wire faces outwards. There we go. Now we have our ESC wires plugged in. We can move on to the next step. Okay, now it's time to wire your ESCs to your motors. So there are 2 directions that your motors are going to be spinning in, clockwise and counterclockwise. And as you can see here on this photo, which is just downloadable from Google Images, if you just search Hexacopter rotor rotation, it'll tell you which way each one's supposed to rotate. So as you can see, rotor number 1 is supposed to rotate clockwise, 2 counterclockwise, 3 clockwise, 4 counterclockwise, 5 counterclockwise, 6 clockwise. We are just going to be plugging in our ESC wires to our motors. It does not really matter at this point which wire goes where. We are going to later check the rotation of the motors and reverse some of these wires to make sure they are all rotating in the right direction. But for now, you can just plug all of your ESCs into your motors, and we will later get back on to making sure they're all rotating in the right direction. We have all of our motors wired up to our ESCs. It is time to go back into our software and to calibrate our compass so we can arm and check the rotations of all this stuff. Okay, now that you are done installing your compass and GPS module on top of your multi-rotor device, it is time to go back into your APM planner here under initial setup, and under mandatory setup, go down to a section called compass. Here we're going to be calibrating our compass. We're going to press the calibration button in the corner here. And for this, we're going to be moving our multi-rotor device on all of its axes for 60 seconds. So press OK, and let's begin. So there we this success window. And now that we're done with that, we can move on to our next step. Okay, for this next step, we're going to be doing our compass motor calibration. This basically teaches your compass what the interference from the ESCs is like. So what we're going to do is plug in our battery here. You'll hear the motors go beep, 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 beep. That means that they powered up. And you are going to need to bind with your remote and connect to your receiver. So mine is, and plug it into the computer. Okay, so to arm your Hexacopter, what you're going to have to do is take your remote here, and if it's a remote with a high mode, for me, I have to click it into the high mode. And you're going to take your yaw stick and bring it all the way over to the right. And then your red light on your flight controller should stop flashing, and then if you notice, you can bring it up. And then after a few seconds, your Hexacopter will disarm. You can also disarm it by holding your yaw stick all the way to the left. And then your lights will start flashing again. Your red light. Again. And as you can see, it is disarmed. And yeah, so there you go. Now you know how to arm your Hexacopter. As you can see, we are back here on our APM software. And we are in the compass mode here. Make sure to enable the compass here and enable auto declination and select your compass. Mine is the APM with 3DR GPS compass. Once you've done that, you can press compass motor calibration. For this, you're going to bring your throttle up to about 50 to 75%. Leave it there for around 10 to 15 seconds, and then bring it right back down again. Oh, you can start with it. Yeah. Okay, now you can press OK. It'll say, new values have been stored. Basically, right now, as you can see, my interference levels are extremely low. So now you can press OK, and now you're done. We can move on to the next step. Okay, now it is time to make sure all your motors are moving in the right direction. So, as you can see, this photo here explains which direction your motor should be going in. As you can see, 1 is clockwise, 2 is counterclockwise, 3 is clockwise, 4 is counterclockwise, 5 is counterclockwise, and 6 is clockwise. So in this, you're going to make sure each of your motors is spinning in the right direction. If your motor isn't spinning in the right direction, to reverse it, simply disconnect and reconnect 2 of your ESC wires, and it should reverse it. And if it doesn't, you can just do it for another 2, and so on until you finally get it spinning in the right direction. First, you're going to want to arm your Hexacopter to be able to get your motors to spin. There you go, and you want to make sure you have your battery plugged in. You want to bring it up to a very low setting, and then start checking your motors by simply just letting your finger rub against one of the motors, and you can tell this motor is spinning this way, and because my Hexacopter is facing this way, just like this photo, this is motor number 4, and it is spinning counterclockwise. Motor number 1 is spinning clockwise. Motor number 5 is spinning counterclockwise. Motor number 6 is spinning counterclockwise, just like it should. Motor number 2 is also spinning counterclockwise. And motor number 3 is spinning clockwise. Perfect, so all my motors are actually spinning in the right directions. This is really rare that this actually happens on the first try, but if you didn't, for example, you could just disconnect these 2 ESC wires here and swap them. Now that you've checked that all your motors are spinning in the right directions, it's time to zip tie up your ESC wires. To do this, simply grab all your ESC wires and your bullet connectors here, which is what these are, kind of bunch them together and fold them like that, and then you're going to store them under your arm, just like this. And to hold this in place, you're going to use a small zip tie. There you go. Now that you have all of your ESC wires zipped tied down to your arms, it's time to install your propellers. Okay, so first, next up, we're going to be installing our propellers. So to install our propellers, you have to make sure we're using the right type of propeller. To make sure we're using the right type of propeller, we're once again going to use this photo, which is right here. And so for motor number 1, we want a propeller that will create lift when it spins this way. So, for example, this is a propeller that will work for propeller number 1, and this propeller will also work for any other of the clockwise rotation motors. And for example, this propeller will work for any of the counterclockwise rotation motors. What you're going to do is place your clockwise rotation one on number 1, and then continually reference this photo and fill in the rest of your propellers. So there you go. Now that you have propellers on, you can take your caps. You're going to be using the black caps for the clockwise motors and the silver caps for the counterclockwise motors. This is because each cap threads on in a different direction, and you want it to thread in the opposite direction of the rotor spinning, so when it spins, instead of loosening, it actually tightens the cap. And you can use pliers to assist you to make sure these get nice and tight. Okay, you are officially finished with your hexacopter here. It is now time to take this out to the field and test it out. Okay, so I'm about to fly the hexacopter here. I am currently running off of a Turnigy 4S 5000 milliamp hour lithium polymer battery, and as you can see, it's just wired there to the bottom. Keep it on the bottom so it's a low center of gravity. Some people stick it in the middle, but I wouldn't suggest it. So I'm going to arm and then take off.